good morning, everyone, and welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up 78 is on the screen. You shouldn't take long by now with those four. And today we're moving on. Let's see how we do. Okay? Yes, Mr. Q. All right, good. Warm-up 78. So by now, number one should be automatic. Right? So, for the sake of time, addition, you should have gotten, was it 4 plus I? Oh, Q. Hold on. Okay, here we go. Difference. We got -2 plus 9I. We good? Yeah? Let's go. Distributes, we got 3 minus 4I plus 15I minus 20I squared. So far so good, yes? But instead of I squared, what do we substitute, Jacobs? -1, that is correct. So this is 3, combine these, that is 11I, positive, and then this is positive 20, because -1 times -20, combine, oh snap, 23, Michael Jordan, plus 11I. Hands if you got that? Yes? All right. Let's go to number 2. This is going to be interesting, because notice I didn't say what method to use to solve that. You could have used any of the 5 methods. Remind your neighbor what 5 methods we know solving quadratic equations. What 5 methods do we know? Very good. Graphing. Square roots. Yeah, we got graphing. Even though, okay, sorry. Let me rewrite that. My bad. Wow. Graphing. Square roots. What's the other? Factoring. Quadratic formula was the last one. And completing the square. Which method would you use? We can't use square roots because this one has a trinomial now. So the easiest to me, I think it would be either completing the square or factoring. I'm going to use factoring. So set this equal to 0. X squared minus 4x minus 6 equal to 0. Factor, -6 and -4. What two numbers multiplied give me -6 that when you add them give us -4? Nothing. So that means we can't use factoring. That means no factor, no square roots. I'm not going to graph. Completing the square or quadratic formula? What do you guys want to use? Completing the square? All right. So therefore, what do we do? Add 6, add 6. We end up with x squared minus 4x, empty space, equals 6. What do I add here? Tell your neighbor, and then Brandon's going to enlighten us. What do I add there? All right, Brandon Felix. -4/2 squared. Add -4/2 squared. So this is x squared minus 4x plus 4 equals 6 plus 4. So this is 10, and x squared minus 4x plus 4. What do I do next, Anthony D? Power Rangers or the shortcut? Square root of the first, square root of the last, sine of the middle, squared equals to 10. Continue from there, Anthony E. Square root, x minus 2 equals plus minus square root of 10. For the sake of time, we're going to leave it exact. So what's my last step, everyone? Add 2 to both sides. So x equals 2 plus minus square root of 10. We good right there, Dom? Yeah? All right. Not bad, not bad. That was number 2. Let's go to number 3. Oh, yeah, let's go. It says graph f of x equals x squared. By now, that should be automatic, yes? Yes, Mr. Q. All right. But once again, being that it's Monday and it's going to rain, it's okay. I got you. Here it goes. If I graph x squared, so I start with negative 2. What is negative 2 squared? 4. What is negative 1 squared? 1. 0 squared? 0. 1 squared? 1. 2 squared? 4. All right, so here's my f of x. Next, they want us to write a rule using all these parameters. So you wrote this, but instead of a and b, we write 1 and 1, 1 and 1. And instead of h, we write 5. And instead of k, we write negative 7. So g of x equals 1 times f of 1 over 1 x minus 5 minus 7. Since it's a quadratic, we put a little squared. So do we need the 1 here and the 1 here anymore? No. So this becomes g of x equals f of x minus 5 squared minus 7. So according to this, where are we going to move our function? Dom. Hold on, let me help you out. Oh, good. All right. People used to say, Mr. Hugh, why don't you share the coffee? I am. I'm sharing the moment with you. Woo-wee. Help him out, Jay. Where are we moving this to? 5 to the right. Yeah. Let's go. 5 to the right. And 7 down. Negative 7 and 5. So it should be somewhere down here. That is correct. All right. Not bad, not bad. Let's go to the last one. Number 4. Systems of equations. I'm giving you plenty of practice, guys, because all of this is coming back. But imagine you're like at the beach, on the beach cruiser. Then the wheels are on fire. The seat's on fire. Everything's on fire. So I'm giving you plenty of practice before we get there. Substitution. According to this, y is what? 2x plus 3. So on the second one, instead of y, I write 2x plus 3. And all that equal to x minus 2. Get all x's to one side, so I subtract x. I have x plus 3 equals negative 2. And of course, I subtract 3. X equals negative 5. Am I done? No, Mr. Q, because that's only the x portion of our answer. So that is negative 5. What do I do next? Tell your neighbor. What do I do next? Trinity, what do I do next? Substitute x into one of the equations. That's why this method is called what? Substitution. So I'm going to substitute this into which one do you want to use, Trinity? First one or the second one? The second one? Okay, I'm going to use the first one. Y equals 2 times x plus 3. Does it matter which one we use? No, we should get the same answer, right? So then it's negative 5. So therefore, y equals negative 10 plus 3. So y equals negative 7. This is my solution. Remind your neighbor what this means, please. What What does that mean? What does that mean? What does that mean? Jay, pass them one. Brandon Felix, what does this mean? We're both if we were to graph these, we're both. That is, in a sense, true. We're both are going to be equal at that point, but that's where both graphs, what? Intersect. All right? Did everybody send that in already? Yes? All right, agenda, copy this. Warm-up 78, complex numbers. We're moving on today. That's why we need a new FAIR model. And tonight's home play, complex numbers, play sheet numbers 1 through 18 only. You're like, what? Oh, yeah, I got you. 1 through 18. Now, if you've been doing the warm-ups these past 2 weeks, you're pretty much done already. You haven't even seen the home plate, but you're done because I already gave you all the practice that you needed on the warm-ups. You're like, thank you, Mr. Q. You're welcome. I got you. All right. Bless you. You do need a code for tonight's home play so you can access the play sheets. I'll give you guys a little bit more time. Let me send the agenda to your screen, and then let me post the code up here. The code that you need is QUGDY. QUGDY. And those of you that are following us on YouTube, once again, if you want access to extra practice, just get that code, log into nearpod.com, and that's how you get access to the play sheets. Okay? All right, we good? So, with that said, over the weekend, I should have a great weekend, yes, after our pop party on Friday. Let's go. That was good, wasn't it? Anyways, I still haven't gotten to correct those yet. I'm going to be doing that this week. But retakes, here it goes, retakes for that one. If you're one of those that you sense a disturbance in the force, come in tomorrow or Wednesday during advisory to retake that pop party. Okay? Yes? All right. So, here we go. I can define and compute complex numbers. I can define and compute complex numbers. I can define and compute complex numbers. So what goes in the center of our FAIR model? Complex numbers. Oh man, that's good. Hit the spot. All right, we good? So, get a FAIR model going. We're moving on to complex numbers. Now, I did a small or a nice, smooth introduction at the beginning of the school year, but today we're actually just going to focus on complex. See if you remember. I started you guys with a table, and we did real numbers on the left side. You guys remember that? Then we did imaginary on the right side, and then at the bottom, we wrote a what? A complex number. So, what is a complex number? Definition, write this down. Numbers that contain one real number and one imaginary number. Let me repeat that again. Numbers that contain one real number and one imaginary number. Some of you are elsewhere. Focus. Numbers that contain one real number and one imaginary number. Examples. 5 plus 3i, 12 minus 6i, 2i, and square root of negative 8. All right? So, before I show you the none examples, look up really quick. So, Complex numbers, students, complex numbers. Here we go. So before I move on, look at this one right here. There's two parts in that number. Tell your neighbor which one is the imaginary and which one is the real number. Which one is the imaginary, which one is the real number. All right. Vianney, go. 5 is the real. I'm going to do that in blue. And 3i is the imaginary. How did she know that it was imaginary? Martin, well, how did she know? The I. All right. So, with that said, I'm pretty sure this is obvious, yes? Tell your neighbor which one is real, which one is imaginary. Ryan, go. Close. Negative 6i. Very close, very close. Remember to include, it has a negative included with that coefficient, and 12 is the real. Okay. Here goes the challenge, though. Which one's the real and which one's the imaginary? Talk it over your neighbor. Let's go. How about Brandon Felix? Pass it to someone. We'll start with the obvious one. The 2i, yes, that's the imaginary. So which one's the real? Nothing. Can't be nothing, but it's close. Jacob M. 0 is correct. Plus 0. That is correct. That's my real number. All right, and of course this one we need to rewrite it. Is that correct? So this one can be rewritten as square root of -1 times square root of 8. Square root of 8 is the same as square root of 4 times square root of 2. So this is 2 square root of 2, and this is I. So therefore this is my what? Imaginary. So tell your neighbor what would be the real for this one as well. 0. That is correct. All right? So these are complex numbers. They need to have both. So let's move on. Non-examples. 23 Michael Jordan. X squared plus 3x plus 2. And -3 plus x equals 10. Tell your neighbor why those are not complex numbers. Why are those not complex numbers? Then we're going to pass it to, we haven't called on in a while. Anthony D. We haven't called on. Let's go. All right. So, Clarissa, why are these not complex numbers? Let's go with the first one. It's a real number. Squared, it's got variables, so this is just a regular what, guys? Expression. An equal sign is an equation, and that's not a number. If it has an equal sign, it doesn't have a number. So, copy this hashtags right here. Hashtag imaginary plus real, hashtag imaginary. So if you have an imaginary number by itself, you know that the real number has to be 0, and imaginary plus real, then that's your complex number. Okay? We good? Yes? All right. Man, I think I'm going to have Anthony D pass it to everybody today. He's on the roll. All right. Here we go. Copy this one, example number 1, underneath your FAIR model. 7 plus 3i. In blue, circle the real number. In red, underline the imaginary. Show your neighbor. For this one? For the home plate. Give me a second. I'll go back in a little bit. All right, we got it? Yes? So, Clarissa, pass someone. Bree, real number. 7, imaginary. 3, I. That is correct. Hands if you got that. All right. Next one. Don't copy that one. Let me send that to your screen. Label the real and label the imaginary on the screen. Right now, what I'm trying to clarify is just getting that out of the way so that we understand what we're looking at. Okay. My goodness, some of you are writing with your feet. Come on, people. My goodness. All right. So, real is 5. Imaginary is what? Negative 2i. Yes? Okay. Next one. Copy this one on your paper. Example 1, supercube. Negative 5i. Identify the real number and identify the imaginary number. Do that on the screen, but also do it on your paper. All right, help us out, please. Kimberly, real number. Help her out. Jacob, A. 0. That is correct. If it doesn't have anything, just write a 0. And of course, everyone underlined negative 5i, negative 5i as our imaginary. Okay? And the last one. Don't copy this one. Tell your neighbor the real number and tell your neighbor the imaginary. Real and imaginary. All right. Emily P., go. 0 for real and imaginary 7i. From 1 to 5, how comfortable are you understanding what we're looking at? Yeah, we got this, right? Shall we crank it up a bit? Oh, yes. Let's go. Q. Copy this one. Example number 2. 2x plus 5 and, this is a symbol for and, x minus 3. They want us to find the sum, difference, and product. By now, you should know how to do that because I gave you guys almost 2 weeks of practice, yes? All right, so do that, please. I'm going to give you a head start. Sum, difference, and product. I'm going to do some in green. Oh, yep. Difference in red. Product in blue. All right. So here it goes. For those that are a little bit behind, here it goes. 2x plus 5 plus, that's what the sum is, x minus 3. So since there's no numbers in front of the parentheses, I just combine like terms. What is 2x plus x? 3x. What is 5 plus negative 3? That's 2. Hands if you got 3x plus 2? That is correct. Let's go to the difference. 2x plus 5 minus x minus 3. So this one is where it gets a little tricky. What is the invisible number here next to the negative? A 1, so that means we're going to distribute the negative 1 in here and here. So this becomes negative x plus 3. Now we combine. What is 2x minus 1x? X. What is 5 plus 3? 8. And that's the difference. Are we doing good? And the last one, product, which means we multiply 2x plus 5 and x minus 3. I'm going to use the Schroeder property, 2x times x, 2x squared, 2x times negative 3, negative 6x, 5 times x, 5x, 5 times negative 3, negative 15. So therefore, 2x squared, combine like terms. This is negative 1x and minus 15, and we are done. Hands if you got that by yourself. We got this, yes? All right. So, which takes us to your home plate. This is exactly how the home plate is going to go. Example 3. Find the sum difference in product of 5 plus 7i and negative 2 plus 9i. This is the exact home plate, guys. I mean, minus the numbers. You're going to see different numbers, but this is the process. Okay? Let's see how you do that by yourself. I'll give you a head start. Once again, if you've been doing the warm-ups, this should be a piece of cake. Huh, Brandon? Oh, I was going to say Darty. Okay. Brandon Darty. All right. Stop real quick. Show your neighbor what you got for the sum. Make sure they have the same thing. What did they get for the sum? Sum. Okay. Continue. All right, so the sum, I'm going to start it with green. I got 5 plus 7i plus negative 2 plus 9i. What'd you get for this one? Noah, go. Yeah, the answer. For the sum, just see it. 3 plus 16i. Hands, have you got that? That is correct. So if you just combine 5 and negative 2, that's 3. 7 plus 9 is 16i. Remember, the I always goes at the end for complex numbers. Difference. Again, 5 plus 7i minus negative 2i. I'm sorry, negative 2, my bad. Negative 2 plus 9i. Pass someone, Noah? Martin, what'd you get for the difference? Still working on it? Okay, I'll come back to you. Product. We got 5 plus 7i and negative 2 plus 9i. All right? Help us out with that one. Who's behind over there? Oh, Bailey. Go. What'd you get for the product? All right, then help me out. What do I multiply times what? Negative 2 times, and that is negative 10. Okay, so then 5 times, that is, what is it? 45i. Okay, next, 7i times negative 2. Negative 14i, and 7i times 9i. Bless you. 63i squared. All right, so far so good. negative 10, combine these, that is it 31? 31i, and then bring down the 63i squared. Are we done? What is I squared, everyone? Negative 1. So therefore, let me scoot this up a little bit. Therefore, negative 10 plus 31i minus, because it's 63 times negative 1, that's negative 63. Combine the numbers or the real numbers by themselves first, so that is negative 73. Bring down the 31i, and that is our product. Hands if you got that by yourself. Let's go! Let's go. And who had the difference? Martin. What'd you get, Martin? 7 minus 2i for the difference. Hands if you got that. That is correct. Let's go. Send that in, please, as soon as you have it. How do you feel for the home plate? From 1 to 5, how comfortable are you with the home plate? We got this, right? 5, yes? All right. So, since we had plenty of practice on the warm-up, notice, once again, for those of you that are skipping the warm-up or that you leave for the restroom during the warm-up and you miss part of it, you're missing part of the practice of what's coming 2 weeks after. And pretty much this is half the session today. So therefore, please, pretty please. All right? Now, I'm not going to give you this next one because we already know what to do and so on and so forth. So we arrive at the following. Writing utensils down, look up to the screens. So this is a section that I like because before I came into education, you all right, Anthony, over there? Good. Before I came into education, I was in the technical field. I was a mobile electronics specialist. So I don't know if you've seen those cars or those programs where they strip the entire car and they install new lights and sound systems and alarms and a bunch of gadgets. That's me. That's my world. I know like how to do all that. So today we're going to be talking about electric circuits. Look up to the screen. Has anybody seen these before? Yeah? So here's a light bulb, here's a battery, and here's a switch. These three make an electric circuit. Now that's in 3D. There it is. I mean 2D right now because it's only black. But if I was to ask you to draw that diagram, it should look like this. Here's the lamp. Do you guys see the lamp here? There it is. Do you see the switch? Yes. And here's the battery. Okay? Today you're going to learn how to identify circuits like this. But we're going to focus with three components that make an electronic circuit. Now check this out. This is a simple one. Now you have in your pockets, those of you, and some of you that are using them right now, these. These are more elaborate circuits. Have you guys seen those before? Yeah? And if you were to break your phone and open it up, guess what? You're going to see that inside of your phone. All phones have those kind of circuits. They say, now check this out, that when man or men first stepped on the moon, all the technology that went into that rocket, now you have it at your fingertips. Think about that one. All the technology that went into that rocket that went into the moon, now you have it in your hand in that cell phone. Why? Because of all these what? Circuits. All right? So with that said, copy this table, please. I'm going to give you the basics of electric circuits. So electric circuit, make a table. On the left column, you're going to label that circuit component. On the right side, symbol is symbol and circuit diagram. Copy that. I'll give you some time. All right, here we go. First circuit. Look up. It's known as resistor. Resistor. Now, an easy way for you to remember this, pay attention. Some of you that are distracted with your Chromebooks, here it goes. Who's seen the old type of light bulbs that are not LED, that in the right where the light, like all of a sudden it becomes light? Has anybody seen that it's like a little zigzag type of little wire? The symbol for a resistor is that, a little zigzag wire, because that becomes a resistor. The next component, inductor. An inductor you probably haven't seen unless you broke some electronic device and you looked into it. So an inductor is as follows. If I was to get a pencil and get a wire, or you've seen probably this experiment. Let's see if you can do this experiment by yourself. You take a nail. You guys know what a nail is? Those that you hammer in. Okay, take a nail, get a wire, wrap it around the nail as many times as you can, and then connect it to a battery, either a C or D or an A, and all of a sudden that nail becomes a magnet. Why, Mr. Q? Because the wire that's being wrapped around it creates a magnetic field with all that energy going through it. That's why the symbol for inductor is like that, a wire being wounded around something like that. And the third component is known as a capacitor. Capacitor. A capacitor serves as a switch that stops energy from going back from the direction that it came from. Kind of like this. Let's say right now when the bell rings, I tell Brandon Felix, can you go to the door and you're going to be my capacitor so that nobody leaves? And if anybody wants to leave, you tackle them. Boom. He's a capacitor. He's going to stop anyone that wants to go over there. Guess what? They stop. That's why the symbol looks like this. Two hands like stopping against each other. That's a capacitor. It stops any energy going back the direction it came from. Okay? So, tomorrow we're going to get into circuits and labeling circuits in regards to what they are for each component. And I'm going to stop right there. Okay? All right? So go ahead and log out. Those of you that are following on YouTube, once again, your home play, make sure you access the home play with that code that you got. And here's the code one more time, QUGDY, QUGDY. And that should give you access to the play sheet numbers 1 through 18. And basically, it's imaginary numbers, some different than problems. Okay? All right? Stop right there.